All right, so we're gonna find these vertical asymptotes and holes and write the limit statements, but then I'm gonna draw a graph and just talk about what the limit statements mean. Because on your assignment today, you're looking at graphs and deciding which limit statement is true. And last period, I found that a lot of people don't know what these things actually mean. Like they're being able to write it to get the right answer, but really don't know what it means. Yes.
Can you review on how to write it?
Yeah, we're going to do it. Example 3 does all the things. All right, so before I find the hole and the vertical asymptote, what do I need to do first on this problem? I need to factor. All right, does this one have a hole? Yes. So what is the x value of the hole? Yes. All right, so that's the first part of the question, and it also says to write the left and right hand limit for each. So when we're doing that, you're going to do one of two things. You're either going to plug the 3 in to the function, or you're going to do the sign chart on the number line. Which one is it for the hole? The hole you plug in. And so what we are technically finding is the limit as x approaches 3 of the function. But we can't plug the 3 in to the original function, because if you do, you get 0 over 0, and that doesn't tell you where the hole is. So what you do is you, in your brain, just kind of cancel out the x minus 3's, and then you plug 3 in to what's left over. So I'm not really sure why our standards want you to do the left and right hand limit for a hole, but it does. So I'm going to do it. But the left and right should be the same on a hole. They should go to the same place, which in this case is going to be -3. I'm sure there's a good reason why they want you to do the left and right hand limit, but I prefer just doing that. Whatever, it's fine. All right, and then is there a vertical asymptote? There is. What is the vertical asymptote? 5. X equals 5. Good. All right, so when the whole denominator cancels for that factor, it's a whole. Whenever it doesn't, there's something that remains in the denominator, that's a vertical asymptote. And for vertical asymptotes, we do the number line. And on a vertical asymptote, from the left or right, you're either going to approach infinity or negative infinity, because that's what vertical asymptotes do. And so to decide if it's positive or negative infinity, we're just plugging in numbers that are really close to 5, but on the left and the right of it. Okay, and then it's easiest for me to plug into factored form, so that's what I'm going to do at 4.9. And then that's what I'm going to do at 5.1. So then, because on the this means the left side of 5, we're going towards 5 from the left side. I got negative. This one is going to be negative infinity. And on the right is going to be positive. Now, I think I've found, just from what my class did last period, that it's easier for you guys to look at these and get the graph than it is for you to get these from the graph. And I didn't realize that was going to be an issue, but it definitely is. And so this one right here that says, as x approaches 3 from the left, that the graph is going to 5. What that means is, here's where 3 is. So what you do is you go up to where something is graphed. You go to the left side of 3 and just start going towards where x is 3. When you get to where x is 3, you stop. And then that is 5. The y value is 5. Right? This one right here that says, as x approaches 1 from the left, you're going to negative infinity. This is 1. So you go to the left side of 1 where the graph is graphed, and you start going towards where x is 1. What is the graph going towards? Negative infinity. Falling, falling, falling forever to negative infinity. Right? And then this one means as x approaches 1 from the right. So here's 1. We go to the right side. We start going towards where x is 1. The graph is going towards positive infinity. So hopefully that makes sense. If not, you're going to know it whenever you start doing the assignment for today. You're going to ask me and I'll help you. Maybe individually it'll be a little bit easier.